Welcome back to our crystallography series. We have journeyed through 6 remarkable crystal systems, each revealing its own secrets of atomic symmetry and geometric beauty. Today, in our final chapter, we encounter the most independent and least symmetrical member of the family, the triclinic system. The word triclinic comes from the roots tri, which means 3, and clinic means incline. So, the name indicates its defining feature, which is there are 3 axes, each uniquely inclined. In the triclinic system, the crystallographic axes are all of different lengths and intersect at angles that are all unequal and none of them are at 90 degrees. As you can see in this diagram, A is not equal to B is not equal to C, and alpha, beta and gamma are not equal to 90 degrees. You can imagine a box that's not just stretched but leaning in all directions, every face slanted and every corner misaligned. This is the ultimate in geometric freedom, a unit cell where nothing lines up perfectly or repeats at regular, easy intervals. So, what does this mean for symmetry? Here, we reach the lowest possible symmetry in the world of crystals. Triclinic crystals are the rebels. They lack virtually all the symmetry elements that define the other systems. Unlike monoclinic crystals with their single twofold axis of rotation, triclinic crystals possess no axis of symmetry at all. You can spin a triclinic crystal in any direction and it will never look the same twice, not even after a 360-degree rotation. No rotational symmetry here. Triclinic crystals also have no mirror planes. Place a mirror through any part of the crystal and there won't be a half that reflects perfectly onto the other. The atomic arrangements are just too unique and too skewed. There is, however, one exception. In the pinacoidal class, also called triclinic normal, these crystals may have a center of symmetry, which is a point at the heart of the structure such that for every atom, there is a matching partner directly opposite. But even this small symmetry isn't always present. In the PDL class of the triclinic system, not even a center of symmetry exists. Most triclinic minerals fall into the first category, possessing only this modest inversion center. Because of all this, the triclinic system is truly the free spirit of crystallography. It allows atoms and molecules of nearly any size, shape, or orientation to build up an ordered solid without strict geometric requirements. Forms in the triclinic system reflect this total freedom. Most often, all faces are irregularly arranged, and the unit cell's parameters create shapes best described as distorted parallelepipeds, which means there are trapezoidal cubes on every side. Sometimes, simple forms feature just 2 parallel faces, which are known as pinacoids. This is the only hint of regularity in a world of skewed edges. Triclinic minerals are perhaps the best showcase of atomic flexibility. Famous examples include the kyanite, which is known for its blue blades and variable hardness. Kyanite's crystals are always unique and asymmetric. Turquoise is the iconic blue-green gemstone, which forms intricate, irregular crystals that owe their appearance to the triclinic system. Microcline and plagioclase feldspars are major components of granite. These feldspars often show a subtle but definite non-rectangular tilt in their crystal lattices. Rhodonite, axinite, albite each come with fascinating shapes and optical properties driven by the underlying lack of symmetry. The habits of triclinic minerals range from blocky to completely irregular, sometimes almost amorphous. Their cleavages and angles vary, reflecting the absence of symmetry constraints. Despite their disordered nature, triclinic crystals demonstrate that beauty and order in nature need not arise from perfect symmetry. Sometimes the story of a mineral is written in its exceptions, its freedom from rules. The triclinic system is a celebration of diversity, flexibility, and the power of atomic arrangement. As our series comes to a close, remember, the world of crystals is an intricate balance between symmetry and individuality. Every mineral tells a unique story. Some are written in perfect polygons, some in beautifully asymmetric forms. Thank you for joining this journey from the strict order of the cubic system to the complete freedom of the triclinic system. Keep exploring, keep learning, and always look for the story hidden within every crystal.